I'd like to introduce today's presenter, Dr. Sydney Crawley.
Hey, great. Happy Friday, everyone. So I'll turn my camera on now so everyone can see me for a minute. I'll turn it off during the talk, and I reduce the bobbleheads in the corner. That's always really distracting to me. But as I said, my name is Sydney. I'm an assistant professor at NC State. If you guys are familiar with Mike Waldvogel, I did take over. I sort of took over his position. They added some extra research responsibilities, but the role is essentially the same. So yeah, happy to consult with anyone offline. If I don't answer any of your questions here, or if you have more questions or just want to chat, please feel free to email me at the email listed on this slide. But with that, we'll go ahead and get started because we don't have a ton of time. So we'll turn this off and we'll get rolling. Maybe. Maybe not. There we go. Okay. So I wanted to start the presentation by talking just a bit about the huge impact that mosquitoes have both on humans and animals as well. Firstly, mosquitoes are the most important arthropod impacting human health. That's globally, not just here in the United States. In fact, in 1878, mosquitoes were actually the first arthropods formally implicated as intermediate hosts of vertebrate parasites. So their greatest notoriety comes from their ability to transmit pathogens that cause an array of diseases: malaria, filariasis, encephalitis, yellow fever, dengue virus. But here in the United States, mosquitoes are mainly despised by people just due to the discomfort that is caused by their biting. But two common pathogens you should be aware of here in the US specifically include West Nile virus, which is big here in North Carolina for sure. That impacts birds, humans, horses, and we've got dog heartworm as well. That obviously negatively impacts dogs. That's the name. But a lesser advertised issue with mosquitoes too that you should have in the back of your mind is their ability to cause significant blood loss in populations of livestock and other herd animals. I mean, obviously the mosquito population has to be pretty dense for that to happen, but it does happen, and that leads to a significant loss of productivity from livestock as well as early deaths of animals as well. Nearly every state in the United States is showing West Nile virus activity. This virus is the leading cause of mosquito-borne disease here in the United States. There are not any vaccines or medications to treat West Nile virus in humans, and about 1 in 150 people do develop severe and sometimes fatal illness from this virus. So the cycle starts when infected mosquitoes bite birds. Birds then serve as an amplifier host for the virus, so just more and more virions get produced in the bird. Then humans and horses serve as dead end or incidental hosts of the virus. So birds, horses, humans all can get ill from West Nile virus, even though it, replicates in the host in a different way, depending on what species you are. If you do happen to see an accumulation of dead birds in your area, it's not a bad idea to have the carcass screened by a public health agent just to see if it is positive for West Nile. You can't get West Nile directly from a dead bird, only through the bite of a mosquito, which again makes them obviously very important vector to be aware of. Now I have this graphic for Raleigh. I don't know why people think Raleigh-Durham is the same thing. It's not. It's two different cities. People do this a lot. It's fine. I looked up Pennsylvania as well. I can't look up every single state. I think the trend is about the same. Obviously, things are getting a bit warmer. Climate change is bringing in a lot more mosquito days per year. And what this means for us is a longer window of pathogen transmission, more days that we need to be aware of mosquito activity, more days that we need to be engaging in mosquito control. So we just need to be aware that people are going to be bitten and complaining about being bitten more frequently than in the past. So researchers landed on these numbers you see here by taking an average of the number of days per year that mosquito temperature and humidity requirements for survival were met. So you see here in Raleigh, we've gone up pretty significantly. In Pennsylvania, you've jumped from 153 days in 1980 to 163 currently. So you're at our 1980s average here in the South, up in the Northeast. So what that means is, pretty much around the US or across the US, we've got almost 2 more weeks of mosquito activity per year, I would say on average for most states. So now that we've talked a bit, and I hope you can see at the top of the slide, I'm kind of trying to give you an idea of where we are in the presentation. Where we're at is going to be highlighted in yellow. So moving on from impact into biology. I want to talk a little bit about biology because that does help vector control professionals and researchers develop best practices, especially since traps that we develop for mosquitoes are often very specific to a particular mosquito species. So I wanted to talk for just a bit about how to tell the difference between medically distinct and important mosquito groups. So starting with the egg life stage, which I know a lot of technicians don't specifically look for, but I do think it is important to chat about quickly. So we break groups of mosquitoes down based on how and where they decide to lay their eggs. We're going to focus mainly on 80 species in this talk. 80 species lay their eggs on substrates rather than in or on water. They lay their eggs singly, and for hatching, the water level has to rise and cover that egg to trigger emergence of the mosquito larva. Other groups like Culex species will actually lay their eggs in nice floating rafts. They can contain up to 100 eggs per raft. Those are often laid in a more permanent water source, and they tend to hatch fairly quickly. Finally, Anopheles species, they lay single eggs, but on top of permanent water sources as well, like Culex. The eggs have components on them that allow them to float on top of the water prior to hatching. We also will group mosquitoes by the type of water that they like to lay their eggs on or in. So some species of mosquitoes lay their eggs in standing permanent water sources like a lake or a pond. And those are the same species that tend to lay their eggs in rafts. So often this is Culex. The adults of permanent water mosquito species will overwinter, and then they lay their eggs as it warms up. After those eggs are laid, eggs will typically hatch in 24 to 36 hours, so pretty quickly. And some examples of permanent water sources, like we said, freshwater swamps are a big one, salt marshes, ground pools, swamps, and we already mentioned lakes and ponds. It's of note that these particular species are often the strongest flyers, and I'm going to tell you a bit about why that's important later in the presentation. There are some species of mosquitoes that will take advantage of temporary or more ephemeral sources of water, though. And most of those mosquitoes lay eggs that persist for a really, really long time. They can last over 1 or 2 winters. They'll hatch when it warms up, usually in the late spring or early summer. They are very resistant to desiccation. They can be viable for years and years. Most of these temporary surface water mosquito species lay their eggs near water that comes and goes, like in a tree hole, for instance. And these eggs are triggered to hatch when water fills the area that they're laid in. So examples of temporary surface water sources you should be aware of, these include tidal pools and salt marshes, rain pools, flood water, tree holes. Obviously, after a rain event, rain that lands in man-made containers, that's really important to be aware of. And we'll talk more about that right now. So some people refer to artificial container mosquitoes or mosquitoes that lay eggs mostly in man-made areas as domesticated mosquitoes. These species will take advantage of things that humans build and lay their eggs in them. So they have similar egg laying patterns and hatching patterns as temporary surface water mosquitoes. And things that you should watch out for when you're inspecting for these species include things like flower vases, tires, buckets, aquaria. I've seen people leave aquariums outside for months and months. They fill with water. They'll produce thousands upon thousands of mosquitoes. And even bottle caps, things that are really small too. Really, any man-made item that can temporarily hold a small amount of water can produce adult mosquitoes. So after the eggs hatch, normally, like I said, they'll hatch in a few days. Larvae will emerge. They're often called wigglers. I know a lot of people here in North Carolina, I hear that all the time. And that's due to their jerky movements throughout the water. So all larvae develop in water. They go through 4 different instars, which means they molt or shed their skin 4 times. Those molts are triggered by having the right amount of food. It's triggered by the number of other larvae in the environment. Often what you'll see is if you have a really dense container full of mosquitoes or area of mosquitoes, it actually takes them a lot longer to go through all 4 molts. If there are predators present, they may molt a lot faster to get out of that environment quickly. Warmer temperatures helps them molt a lot faster. So all of those factors kind of impact how long the process takes. So it's really variable. But after that fourth molt, larvae will turn into pupae. People call them tumblers because they come up to the top of the water and then they sort of tumble back down. This life stage does not feed, but they are very active in the water. And then at the end of that pupal stage, the pupae come up to the water surface, their skin will split, and the adult then emerges on the water surface. They'll dry off their wings and then fly away from that point. I did want to take a second and look a little more closely at the larval and pupal life stages, because getting a handle on these two stages really can put a huge dent in the adult mosquito population. So as we discussed, the eggs hatch into larvae. Those live underwater. They feed on bacteria and other microorganisms in the environment. They do have to come to the surface of the water to breathe. And some mosquito species will actually use a siphon to breathe. Anopheles species do not. They have a spirocular plate. I'm not going to ask any questions about those sort of specifics, just something to be aware of. But you can actually see the siphon, like on this larvae here at the top. A lot of times you can see those sticking out of the water. So that is one way you can tell apart some of the major species of mosquitoes by looking just at the larvae. Anopheles with that plate, they lay flat on top of the water instead of sticking that siphon out through the top. So under optimal conditions, I said that, this process of molting is variable, but if things go well, it takes about 7 to 10 days for larvae to turn into pupae. Pupae complete their development, again, ideally in 1 to 3 days. They do not feed, but they will come, as you see this pupa doing here, they will come to the surface just like larvae so that they can get oxygen. So to sum all that up, and let me see if I can play this video. It did work earlier. Here we go. So there you can see some active movement of larvae in the water while I go over a few more facts. So to sum it all up, development time from egg to adult is usually 10 to 14 days. So it's very, very quick. Eggs hatch in 1 to 3 days for those permanent water sources. The temporary water source mosquitoes, it can be as many as 5 years that those eggs can stay viable and continue hatching. The larval life stage will last 7 days up to a few weeks, depending on the environment. Pupal stage, 2 to 4 days to a few weeks. And then adult females, they can live 1 to 2 months, whereas males are a lot shorter lived, maybe 6 to 7 days. If it's an overwintering species, females can live 6+ months. So with that, here's a few more things to keep in mind about mosquito biology. The most important thing to know about mosquitoes that helps you gain control of a population is that they have to have water. They really need a lot of moisture to complete their life cycle. They've adapted to really every aquatic situation that you can think of. I'm sure everyone knows this. Only female mosquitoes take a blood meal. They use that as their protein source to produce their eggs. They can feed approximately once every 2 days. Both male and female mosquitoes will also feed on plant nectar. They use that sugar as a source of energy for flight. And then mosquitoes are diverse. So there are over 3,000 species of mosquitoes worldwide, and not all mosquito species will feed on people. That's something to educate customers about. If you see a small flying insect, it doesn't necessarily mean that you have a biting mosquito. Some non-biting mosquitoes in their larval stage are actually predators of other aggressive biters of people. So that's just something, I like to tell people who are freaking out about every small flying bug they see in their backyard. And another way you can utilize information about mosquito biology in a really helpful way, I think, is by looking at their resting behavior. This is a handy way to ID mosquitoes on the fly. You can tell the genera of mosquito by looking at its resting angle. So Anopheles, the picture here at the top, I think is really helpful. Anopheles will rest with their abdomen upright at about a 45-degree angle to the surface. Aedes will rest completely parallel to the surface, while Culex will rest with their body up in parallel to the surface. So for all the species that we're talking about here, when they're resting, they like to rest in shaded areas, usually in dense vegetation, tree cavities, animal burrows, root masses. The more domesticated species will actually rest indoors as well. They love areas with low light and wind, And their cryptic resting behavior is one reason why sometimes we have a hard time targeting and treating and getting control of a population. A lot of people will come in and ask me why people won't, treat their entire yard for mosquitoes. And one thing to point out is, that's often just not necessary. They're not going to rest on blades of grass out in the open sun. So like a lot of times, broad scale treatments are just not necessary. There we go. Another thing that's important to talk about when we go over mosquito management is their feeding behavior. So different mosquito species feed at different times of day. I was actually working on a protocol for someone who wants to look at behavior of 80 species, and they wanted to do the trials all at night. So the time of day that mosquitoes bite, it does depend on the species, and it is important, especially if you're running control trials. Feeding will start 1 to 3 days after emergence. Many medically important species are going to bite at dusk and dawn, and some of them will bite during the night as well. But some only bite at dusk and dawn, like the salt marsh mosquito. But an aggressive biter and one of the most discussed nuisance species, the Asian tiger mosquito or Aedes albopictus, they will bite during the day. They're diurnal, whereas Aedes aegypti will bite at dusk, dawn, as well as during the day. But yeah, someone wanted to work with me on an albopictus experiment, and they wanted to do it at night. And I had to talk about why that maybe wasn't the most appropriate time of day to run the trial. So knowing these things are really important. And if you can get a client to tell you when they're experiencing biting, it might help you get a handle on what species that you're dealing with. Also, setting client expectations. Knowing how far a mosquito can and will fly is also a really important piece of mosquito management. Salt marsh mosquitoes, which I do deal with down here, especially after a big rain event or a hurricane, they tend to be the strongest flyers, and they can fly up to 5 to 10 miles. Whereas domesticated species like Aedes albopictus don't tend to go super far. So knowing that is really important, because if you find an eastern or a black salt marsh mosquito in your region, but you can't find the source, the problem that a client is dealing with might not be your problem to solve. The issue might be 5 to 10 miles, down the road. But if you find Aedes albopictus, you can be fairly certain that the issue is coming from 1 to 300 yards from where you found a sample. So again, something important to help tell clients that are very anxious. Sometimes, unfortunately, you can't get control of a situation if it's not in the region. And that helps prevent a lot of callbacks and dissatisfied customers. Last thing I want to end on before our first code word, since we've wrapped up biology, I did want to talk about a few lookalikes. I've had a lot of people call me out for a mosquito problem when really the issue is something completely different. So 3 of the most common lookalikes that I get, and I'm sure you guys have more examples, but Dixid midges, those species, their wings don't have any scales like mosquitoes do, and their body is also bare without any hair. The biting midges usually have very, very long front legs. Again, no scales on the wings, and a very short proboscis. And then crane flies, my mom as a kid, she always swore to me that these were male mosquitoes. And I went to graduate school thinking that crane flies were male mosquitoes. It took a very long time to unlearn that. They have no scales on the legs. The body is bare. And of course, legs are very long, and they're way bigger than mosquitoes that you're going to encounter when treating most people's backyards. With that, finally going to get into the management piece, which I know is what people are usually most curious about. So like many urban and medical pests, you're probably seeing a lot now, like people don't just want to rely on chemicals to do pest management. We're kind of approaching everything now with a more integrated approach. For most insects, we call that integrated pest management, or IPM. People are, kind of snobby with mosquitoes. They have to have their own term, and that is integrated mosquito management, or IMM. So most of the techniques I'm going to go over today, most of the pieces that you'll see are often done by officials that have a vector management role within, like a vector controlled district. But anyone can use these techniques to help reduce the number of mosquitoes in an environment. And IMM combines 2 different sets of tactics for managing mosquito populations. One set that you're going to use continuously and try to run all the time, and another set that's used in a situation-dependent manner. So that's for when mosquitoes are a problem right now and we need to do something right now. Ongoing efforts geared at controlling mosquitoes long-term include things like, public education, surveillance, and preventative practices. Whereas situation-dependent control, that's going to be more like a chemical application, physical control through trapping, or biological control. So I've broken these up into the headings that you see on the left, and we're going to go through them, one at a time. But I do want to start by saying that the decision to initiate situation-dependent management is dictated by sort of interesting factors. You'll hear vector control professionals say a lot that public pressure or biting complaints, that's not a good reason to treat for mosquitoes. Obviously, all of us in urban pest management know that that's the main time that we get called to deal with a mosquito population. But yeah, far and away, public pressure is usually what dictates vector management intervention in mosquito control. The second most common reason that people treat for mosquitoes is because they've been doing surveys, they've been doing trapping, and they've detected a pathogen in a pool of collected mosquitoes. Third most common is when the adult counts exceed a predetermined public health threshold. And again, often that is tolerance-based and has to do with nuisance biting, because we don't have a ton of mosquito disease spread here in the US, especially in comparison to some other countries. So this is just interesting. It's something to keep in mind, because political pressure is also on this list. And ideally, we wouldn't be applying chemicals based on political requests. I know sometimes that line is really hard to walk. I have to do it all the time in my position. But, in an ideal world, mosquito treatment should be induced when you see mosquitoes, they are present, they are becoming a public health threat or an exceptional nuisance to your customer. The public opinion or political pressure, those things are not a good reason to apply pesticides. So just wanted to throw that out there, because a lot of times people will spray just because someone tells them to. You haven't had a sample collected, you haven't actually seen an insect. I think it is important to get a positive ID before you do the treatment, or you are on a calendar schedule that's, according to the label rate of a product that you've chosen to apply. So that being said, if there is a mosquito problem, oftentimes ideally, again, I know this is a lot of labor and this may not be relevant to you all, but it might be something that's happening through the city or another entity above us that we're not really involved with. But often people will engage in surveillance tactics. This starts with looking at the number of larvae in an area. And the most common way that people look for larvae is just by using a dipper or a small cup. And it's not really used to get a read on the number of mosquitoes in a population, but really you just use this as a presence absence indicator. So if you're walking through someone's backyard and you look through larval sources, you may not even need a dipper unless someone has like a koi pond or something like that, or a pond on the property, but often you can just do a visual inspection and see whether larvae are present or absent. And that's a good way to know whether or not you're working with quite a few mosquitoes. And then a lot of people also try to capture adults just to get a handle on how many mosquitoes are present and where they're coming from. It's important to note that we're not really interested in trapping males since they don't bite people. So most traps are designed to go after females, which do bite people. So often traps are designed around host cues that females are going to hone in on to bite, or they're going to be cues that females use to lay their eggs. So that's called a gravid trap. Gravid females, or those filled with eggs, will get sucked into gravid traps because they're attractive for egg laying. You can also use, I know at Scott's I did a few experiments just using passive traps that just have, a light or a fan that sucks them in. There doesn't always have to be a chemical attractant. When you start adding chemical attractants to a trap, of course, you guys know they often go up very quickly in cost. Because I don't feel like it's relevant to this audience, I'm not going to go into all the specific traps you can use. A lot of times in a backyard environment, we don't encourage people to use traps. That you just have to use a whole lot of them and they can be very expensive. But it's just something to be aware of, that this might be an ongoing city initiative or county initiative to just be aware of. You might be able to talk with them about what the city is finding in terms of mosquito populations and use that information to help your client dealing with an issue. A lot of people too will sample just with a backpack aspirator. Those will collect resting mosquitoes from the environment if you need to take an ID. Some people will do landing counts because the aspirator takes more physical labor and it costs money. But with a landing count, you do risk being bitten, and some people don't want to do that, which is fine. But if you want to prevent that and you've got two people, the second person can use an aspirator to pull them off of another subject before they get bitten. But again, you don't really want to risk pathogen transmission or annoying bites, allergic reactions, and whatnot. So you can also use a net, or if you just are quiet and careful, you can get a good observation just by, again, doing a visual inspection. And surveillance methods are not perfect. We all know this. All the methods we use are relative. None of them are going to give you an absolute population density estimate. You're not going to catch or find every mosquito. And you attract different species and sample them at different rates based on the technique you're using. So there's pros and cons to everything, right? So usually what you're going to have to do is do a quick visual inspection, predefine what species complex you're working with, and then select the appropriate technique based on the species. For instance, you might be treating tree canopies if you know you're working with Culex versus low-lying vegetation for 80s. So I do think being aware of the species in question is really important before you start your treatment. It might impact where you put your product. Whether or not you need to go to the lengths that a vector control municipality would be doing, that might not be necessary. But I just wanted you to be aware that people do it, and you might have access to that data just by asking. Once you have done, so I've got a, more of like a county map here, like a huge indicator of where the hot spots are across a large area. But you can also make one of these maps for a backyard. So that kind of allows you, if you have to, split your effort somehow, or you want to really apply product where you think it's going to have the best chance of working, this allows you to decide where to focus your treatment efforts. I've also noticed that a lot of clients that call me, they like to have this information. And a lot of times people are really willing to work with you as far as kind of cleaning up their yard or getting rid of things that are supporting mosquito activity, mapping out the hot spots for them and showing them on paper where they are, or walking them out and showing them, hey, this is really contributing to your problem. I don't know, it's almost like a seeing is believing thing. It kind of hits home a lot better than just saying it or guessing at it. And it saves people a lot of time, usually in my experience, to make those small maps. So we moved through surveillance, we talked about species ID, we talked about source identification. So how do we reduce where mosquitoes breed? This is the number one way to put a dent in a mosquito population by far. We know that mosquitoes need water to breed. It's often a much smaller amount of water than you think is necessary. So the tip and toss method is what's recommended. You've probably heard of this, told people to do it. It's a great way to get rid of standing water that is attracting egg-laying females. Just keep in mind, again, even super small items like a bottle cap you see on the top of the slide can harbor, 50 mosquito larvae. So don't just pursue the very obvious sources of standing water. Really, a thorough inspection will help you figure out what needs addressing. Backyard mosquitoes and the more domesticated species, they can really make use of almost any man-made item to lay eggs in. So be sure to really look at tires, any, piles of, I don't like to call it junk. I feel like that's kind of rude, but I mean, items in the backyard that have piled up over time, plates under flower pots, bird baths, or bird feeders. I see a lot more bird feeders than I do bird baths. Just check them for mosquito larvae or standing water, or the potential to collect standing water, and communicate that to the client. These things can produce hundreds to thousands to tens of thousands of mosquito larvae over the season if they go unchecked. So just getting rid of things like this can be a huge, huge help. And something that I put in my presentation now, because I've dealt with it in my yard, people don't really talk about it, but top dressing can really help eliminate standing water sources in the yard. My yard was very uneven. There were a lot of divots, and I realized it was collecting a lot of water that mosquitoes were taking advantage of. So it can mean patching holes in concrete. This can mean filling ditches, just any modification to the landscape that makes it more even and fills holes that are holding water. And then if you've got a client with a huge yard, something a lot more rural, you may have to actually completely modify the habitat I know this was a midge example, but I know a community pond was producing millions of midges. And so the developer had to decide, what are we going to do with this pond? Are we going to keep it? Do we just need to fill it in? I mean, the problem was severe. People's siding was completely covered. I mean, it was black. So at some point, if a problem is really terrible, it might be beyond your scope, and you may have to talk to developers about actually completely modifying an environment to change water flow or water presence. Getting rid of dense vegetation can also help. I know people like to have backyard ponds. I know they like to have a lot of flowers and things, but that creates shade. Just having these talks and making people aware, they can decide whether or not they want to make these sort of extreme modifications to their backyard or their environment. With that, we'll move on to chemical control. So when you're treating for mosquitoes, again, everyone knows these things. You can use a larvicide or you can use an adulticide. Obviously, adulticides will kill adult mosquitoes either in flight or while they're resting. And larvicides are applied to sites to kill larvae before they mature into adults. You can use one or both. Obviously, using both in tandem is very effective. I have taken off specific product names on here, but here are the big groups of larvicides that you can choose from. There are smothering agents. These include oils, monomolecular films. I don't see those used as often as other things, if I'm honest, but I know that they do exist and they can be effective. Those prevent larvae from breaking through the water surface with their siphon to breathe. So they basically just suffocate. Clearly, those aren't great choices if you have other aquatic life present in the pond or whatever it is that you're treating. IGRs, insect growth regulators, those are hormone mimics that prevent larvae from developing into adults. Methoprene is a big active for that, pyriproxyfen. So those are added to the aquatic environment to prevent larvae from emerging. Nerve toxins like spinosad exist. And then, of course, bactericides like BTI, Bacillus is a big popular one for that. You often see those in dunk form. I try to tell people, though, when you have a very large source of water, I mean, and most labels will say this, throwing in, 100 mosquito dunks or trying to treat a huge water source just really isn't, it usually doesn't work and it's not ideal. So that's just something people need to keep in mind to set the expectation. When you're looking for sites to put a larvicide, and I know this may not be something you guys do on a regular basis, but again, might be a team effort, or it might be something that even the city is doing. You want to look for the same places that you would for source reduction. So storm drains, retention ponds, ditches, any area that holds water. Just be sure you're following the label instruction and not applying to places where you're not supposed to, just like any pesticide. Okay, ULV sprays are a popular way that, again, municipalities control for mosquitoes. I do work with some pest control companies as well that do this. State and local agencies usually use organophosphates. You guys know this, malathion. And there are also some synthetic pyrethroids that are used, polyethylene, efenprox, resmethrin, sumethrin. So these are meant to control adult mosquitoes that are what we say on the wing. So mosquitoes that are in flight. So obviously you're going to need very fine particles of liquid. These are meant to float through the air. They will kill mosquitoes on contact. You want to focus on sites where mosquitoes are most likely to land and rest. Like I said, these are usually applied by pest management professionals in local government agencies, but I do know pest control companies that do this as well. The ULV sprays that people apply will only provide temporary reduction in an overall population. It is not a standalone treatment. You will get new adults that are going to keep emerging over time, especially in favorable weather and especially with favorable breeding sites. So you're probably going to need to apply multiple times during the year. If people really want to get a handle on a really bad problem, you still have to go through everything we just talked about, a visual inspection, reducing breeding sites, and really identifying the source of the problem. And if you can change the source, doing so. You've got liquid pesticides, obviously, this is a big one. Typically, the way you want to apply these is as a barrier application for small spatial areas like the backyard. These are effective against species that feed on ground-dwelling mammals. very, very often. You can apply it to the canopy, so species that feed on birds and flying animals as well. Usually you want to use a long residual synthetic pyrethroid. This can be used, we all know that people apply on their own, sometimes when they shouldn't, or professionals can apply these as well. I put that mister up there. That was in development when I was at Scott's. We launched it right before I left. And I know we have a chemical, I believe we've got bifenthrin that goes through that. So yeah, this can be done without a license, without any sort of training. But ideally, it's done by a professional who knows where to put the product and how to give the best application. There we go. I was going to say, popular areas to treat include what you see here. You obviously want to follow the label, but often I want to see people doing barrier applications to lower lying vegetation, really getting up and under the leaves. Mosquitoes love to rest on the underside of leaves of bushes and trees. And sometimes you can even apply to eaves. But again, just make sure you're looking at the chemical that you're using. So I think here I put Talstar. Just make sure you're reading the label, using the right dilution. I always recommend the high rate, and it even says here, use the high rate for residual control of mosquitoes. Use this for mosquitoes that may potentially transmit malaria and arboviruses like West Nile and dengue. So that's obviously talking about Culex and 80s, which means you can spray into the tree canopy, or you can hit, like I said, these low-lying bushes that you see on the left-hand and right-hand side of that slide. Typically, you want to treat 100 to 200 yards around an area where mosquitoes are most problematic. But I always recommend communicating with people before you spray. That might involve going next door and just, knock on the door, letting them know what's going on. You have to be aware of potentially sensitive environments in the surrounding area. That can include where kids are playing, where pets are resting. Some people have organic gardens. I did get a call this year where a PCO was spraying and they were doing everything according to the label. They were avoiding drift. They were doing everything right. But someone was concerned about their organic garden. And all they said was, I just would have appreciated a phone call or someone just letting me know what was going on. I'm not upset that they're doing it. I just really would have appreciated someone telling me. And so a lot of times you can avoid people being dissatisfied with just a simple conversation. And it might also get you a new client too, if they feel like you're doing everything really responsibly. So that's something I always recommend people do. Just a quick conversation. A lot of people do have backyard bees as well. I've gotten a lot of calls for this reason too. Obviously, insecticides kill insects and bees are insects. And if you get mosquito adulticide on a bee, it's going to kill a bee. So make sure you're following label directions, obviously. Make sure you're not spraying blooming flowers if you can help it. That's usually prohibited on labels. We had a bee box on a lot of our products. You have to be aware of drift as well. So any amount of drift and application to an area where you didn't want pesticide to go is, illegal. It's a violation of the label. So you really need to follow wind rules, like not spraying when wind is X miles per hour. The label will tell you what that maximum is. You really need to be careful of spraying on blooming crops or blooming weeds. Ideally, you're spraying when bees aren't as active. I know a lot of professionals here assure me that that's their strategy. They try to treat when bees aren't flying around flower to flower. However it is that you avoid it, bee health is something to be aware of. People are very concerned about it. It's very political. It's in the media. We've all seen it. So just make sure you're following the label and being as judicious as possible. And like I have here, when in doubt, just make sure you read the label. It's going to tell you how closely you can apply to waterways, what time of day to avoid pollinators, what equipment you need for most accurate application, ways to avoid wind, ways to avoid drift, whether or not you can apply to like organic gardens, which most of the time you can't with these, right? But there are some products out there you can apply to organic gardens or vegetables for harvest, but all of that is on the label and you just need to be aware of those things. So I said we would come to predators. So some people use predators or they want to use something quote unquote natural. I don't like the word green. The word natural even comes with issues, but a lot of people want an option that is environmentally safe, which again, all of these terms come with issues. We know this, but BTI, it is a good way to control mosquito larvae. This is a biocontrol agent. It's, I'm sure everyone's familiar with it. BTI produces toxins that will kill various species of mosquitoes, even fungus gnats and black flies. while having almost no effect on vertebrates and other organisms. You can spray it over a water body, or you can put it in as bits or a dunk. A lot of people love that option. A lot of people use that option. Other people ask me, are there any predators that I can add to my environment that will control mosquitoes? A big one I get questions about are mosquito fish. They are very aggressive predators. They will eat a lot of mosquito larvae. You can put these into ponds and lakes. Unfortunately, they will displace native fish, and that's not what you want. And they also they don't survive very well in some cases, and you have to kind of replenish the population. Will it work in a small pond in a backyard? Maybe. I'm not saying no. I'm just saying I think there are other things that work better. I think I have, yeah, I do. I'm going to talk about another predator in a moment. But at first, I want to talk about traps. Get so many questions about traps. Usually, a trap will contain an attractant chemical or a light. They'll target a specific mosquito species. I have here, we just talked about it, bug zappers, not super effective, and really they're just great at killing moths. So I don't recommend that people use them for mosquitoes, but traps can catch a lot of mosquitoes. That doesn't mean though that you're really putting a dent in the population. I think someone described it to me as using like a styrofoam cup to scoop water out of a pond. It's just a lot of times you need a lot of traps. I think they're really best served for surveillance. You can use them to control mosquitoes, but it just really depends on how many you put out, what species you're looking to control. And oftentimes it takes a community approach. It's like everyone in a suburb would have to be participating for this to have a huge impact. A few more predators to talk about. Bats will eat mosquitoes that are on the wing. However, they prefer other insects and they prefer larger prey as well. They'd have to eat a lot of mosquitoes to keep up with their nutritional requirements for energy. So yes, bats will eat mosquitoes. I wouldn't recommend putting up bat boxes for mosquito control. Bats are also great reservoirs for a lot of pathogens. Frequently the feeding pattern too of like birds that'll eat mosquitoes, some bats, and a lot of the predators that people ask about, they don't coincide with the biting patterns of medically important mosquito species. So like bats are feeding at night, you got Aedes albopictus feeding during the day. So how relevant is a bat for albopictus control? So it's a good idea in theory, but I think it's less effective practically. And finally, just a blip about personal protection. This is a good way, obviously, to keep mosquitoes from biting you. If people do have to be outside and you're kind of waiting for treatment to work, I just remind people that they need to use an EPA registered on-skin repellent. There are a lot of products out there that aren't effective. There's a lot of marketing tactics in mosquito control that aren't necessarily above board. I know oil of lemon eucalyptus and lemon eucalyptus oil, that distinction is important. And a lot of people try to get away with using them interchangeably, but they're not. And EPA only recommends oil of lemon eucalyptus. IR 3535, picaridin, DEET, obviously, PMD. These are all good things that people can apply if they want to avoid being bitten in the backyard, especially before a treatment has really had time to start working. So in summary, and I'm very happy to see that we're on time with a few minutes for your quiz and questions. You typically you can't eradicate mosquitoes for the most part. They're not really going to go away, especially not season long. So your best bet for a management strategy is reducing or suppressing a population using integrated mosquito management. Finding the source of the mosquito problem is really important. And again, this may mean that you actually can't solve the problem because it's 5 to 10 miles away. So in that case, trying to do localized treatments is superfluous. You need to tell the client, like, look, I can come out here and do these sprays every couple of weeks, but you're still going to see mosquitoes and it has nothing to do with the efficacy of the product. In the United States, mosquitoes are predominantly nuisance pests. We're really lucky in that sense. We don't have to worry about malaria here, for instance, but you do need to be aware of a few pathogens that they do carry. I've emphasized West Nile virus and dog heartworm, but there are others. Equine encephalitis is one, and we have seen that pop up here in North Carolina. So just being aware of the very few that do exist here in the United States. Decisions to treat for mosquitoes are a combination of public tolerance and other factors. often it requires a community-wide effort to make a huge dent, and often we just don't get that. So we do the best that we can. Again, I always recommend, though, treating when someone's seen mosquitoes or they have a significant history of a mosquito problem. And then if people want a way to enjoy their backyard without being bitten, I always do recommend personal repellents, and we go over the safety of DEET and other things. And we go over essential oils and all of that. So yeah, I try to make, a lot of people are very chemophobic when it comes to mosquito treatment. So I just try to stick to the facts. I try to build that trust. I try to explain how pyrethroids work, what pyrethrins are. And I have to say, just having these conversations, giving them facts, a lot of infographics, it's helped dissolve a lot of fear and a lot of anger. So I usually will have a very angry client on the phone. They're mad about spraying, they're mad about fogging. In just a few short minutes, the temperament can really change just by presenting them with some of these facts. So that's usually what I recommend. I'm not saying it works every time, but in my experience, it's been super helpful. So with that, we are finished.
Well, thank you everyone for your participation today, and Dr. Crawley again for this great webinar. Hope everyone has a great rest of your Friday.
Awesome. Great presentation, Dr. Crawley. Thanks.